I am Britt McGinn. I am the sales manager for the SATCOM, or the Aerospace and Defense products at Optical Zonu. We're joined by Dario from Sincron Sistemi, who will handle any necessary logistical elements of this presentation and can provide any translation that may be necessary. If you have any questions, please type those into the chat, the text chat on the right side, and we will address those at the end of this meeting or offline. So my presentation is just now loading. And hopefully you can see that now.
Yes.
Okay, very good. So the theme of my presentation this morning is essentially the capabilities of RF over fiber, RF signal transport over fiber, as it applies to solving problems in aerospace and defense applications. So perhaps the most fundamental or the most common capability that is leveraged in aerospace and defense is fiber's capability of transporting RF signals over very long distances, perhaps even tens of kilometers. When transporting over coaxial cable, even L-band is limited to perhaps less than 100 meters transport. And for higher RF frequencies, the distances are even shorter. The RF attenuation when transporting over fiber is approximately 0.7 dB per kilometer, and that's essentially independent of the actual RF frequency that's being transported. Optical Zonu modules can transport RF frequencies ranging as low as 10 kilohertz all the way up to 50 or 60 gigahertz. In addition to modulated RF signals over fiber, Optical Zonu also transports very low phase noise reference clocks and iRig and PPS timing signals over long distances. So continue with the theme of the capability of transporting over long distance. Add to that the capability of operating in very harsh environments. And as an example of this, I show a system that Optical Zonu has deployed with the U.S. Navy upon U.S. Navy ships. So in this particular application, the transport distance is relatively long, a couple hundred meters. But in this case, we're operating in a very hostile seaborne application environment. On the outdoor unit, which actually, if you can see my mouse, is shown here. The little gray box that is located high above the ship in a radome, and a custom rack mount unit is located in a control room far below the ship's deck. So for this particular application, we're not down converting at the antenna. We are actually transporting native KU band directly from the antenna to the ship's control room. In Mayer's talk earlier, he referred to the eFibersat antenna remoting solution. That's essentially a small turnkey solution that Optical Zonu has developed. It's very modular. We can accommodate up to 4 uplink signals, uplink or downlink signals in the outdoor box shown, and transport those over a single fiber to an indoor unit. We also can accommodate distributing very low phase noise reference clocks to the antenna in the eFiberSat system. And as Mayor noted earlier, these can be configured with bias Ts to control and power elements of the antenna. Another capability or benefit of RF over fiber transport is the very lightweight nature of fiber. So the fiber itself lends itself well to applications on aircraft, or for example, tactical antenna installations, mobile tactical antenna installations. I've shown here some of our small OEM transmitter and receiver modules, Optical Zonu transmitter and receiver modules. The smallest of which, the OZ101 series, a transmitter weighs only 19 grams and has a very small envelope and operates off of 3.7 or 5 volts, so may dissipate very low powers, perhaps even less than 400 milliwatts. So this is very key for applications that require or are constrained by very low size, weight, power. And these are sophisticated modules as well. They can transport up to 6 gigahertz. And the OZ101 modules also have a sophisticated I2C interface for accessing data within the module. To carry the size, weight, power capability further into another application, partners have integrated Optical Zonu components into assemblies that can fly on drones. So in this way, a radio transceiver can be flown within a drone, and essentially a fiber optic link connecting the drone, a tether, connecting the drone to some sort of control system, essentially performs the duty of like a deployable, flexible antenna tower. Mayor noted earlier our Iridium, Globalstar, or more generally our satellite phone application. So another capability of RF over fiber is the distribution of very low signal power, low power signals over large distances. So in this case, in order to use a satellite phone, one must have a line of sight to the satellite constellation in order to close the communication link. Well, in cases where one wishes to use a satellite phone inside of a building or within a tunnel or mine or in a secure area, one must bring that very low-level signal into the building and transport it over large distances. And Optical Zonu has developed a relative turnkey solution for distributing Iridium and Globalstar systems within large buildings or over large areas. And as the figure here shows, Optical Zonu actually has 2 sorts of indoor terminals, or indoor, the termination of the fiber. One is a direct connection of satellite phones to a cradle or a chassis that it terminates with the fiber. We also have a solution where an indoor unit, ceiling mount indoor unit, is connected to indoor radiating antennas, and in this way one can speak or use their satellite phones wirelessly inside. Another capability of RF over fiber signal transport is the fact that, unlike coaxial cable, the RF signals going through fiber do not radiate electromagnetic energy from the waveguide or from the fiber. So in this way, links that are very, very secure and very, very safe as far as radiating electromagnetic energy may be deployed as a kind of a an added benefit to this capability. Fiber is much less susceptible to lightning, and one does not have to concern themselves with ground loops when transporting over fiber. So, as a matter of fact, Optical Zonu has a design win and a solution deployed. We have a design win with the U.S. State Department, in which links such as this, fiber links into and out of secure areas, are deployed in U.S. embassies and consulates worldwide. So again, capitalizing on the capability of the small size and weight of fiber, we can create and integrate very small and light RF fiber optic delay lines. So the example that's shown in the figure here that Mayer also showed in his presentation is actually a spool of fiber that is probably about 14 kilometers long. And through this length of fiber, one can implement an RF delay, a temporal delay of perhaps up to 65 microseconds. So this is coupled with an Optical Zonu fiber optic transceiver. So it's RF in, RF out, with a delay of 65 microseconds. So this can be accomplished in a package small enough to hold in the palm of your hand. And for longer delays, we can integrate those into rack mount systems. I'd like to end with a slide on Optical Zonu's very unique remote management and control capabilities. As Mayor noted earlier, one can manage a large array of Optical Zonu chassis and components from a single agent that's connected via USB and USB hub to many different disparate Optical Zonu elements. So in this way, one may interact with a single IP address and monitor an entire chassis or an entire network of Optical Zonu equipment. I've shown a couple of windows here that give examples of the types of user interfaces that are available. On the bottom is a very low-level, very feature-rich command line interface for doing SSH, perhaps, communication with the Optical Zonu switch. At the top, One may use login and use a very simple web user interface to access and control any equipment, any connected optical Zonu equipment. And in the middle is shown an example. This is our 3RU chassis example of our graphical user interface. And this again is an application that is embedded within the server, within the optical Zonu switch, the optical Zonu agent, and using this, one can look at a system view, drill down to a specific chassis, drill down to a specific module in a chassis, and even sub-slots within a module. Optical Zonu switches also support SNMP version 2 or version 3. And on our S14, the module that's connected to everything on the bottom here, we also incorporate a 4-port layer 2 Ethernet switch. So this may be used to connect optical Zonu equipment or equipment from any other vendor. And I think we have about 3 minutes left. Are there any questions? Let me scroll through the chat. Yes. One thing I didn't mention, also looking again at this network or equipment interface drawing, Optical Zonu also has a patented small form factor pluggable Ethernet transceiver that, in addition to transporting Ethernet data, if there's a fiber fault, the module switch from a Ethernet transport to a micro OTDR function, an optical time domain reflectometer operation, in order to locate the approximate location of a fiber fault. So with that, if anyone wants to take their mic off mute and ask a question, I think we have perhaps 2 minutes left.
Yes, exactly. I don't know if there is some question or soon we will be moved to the main room.
Hello, yeah, I have a question. Can you hear me?
Yes, Michele.
Okay, hello. Yeah, you mentioned about transporting very weak signals. So, what kind of noise figure do you need to achieve for
that? We hear you very low, Michele. If you can go near the microphone. I only understand the noise figure.
Can you hear me now?
A little bit better.
Okay. So I said you mentioned about transporting very weak signals over the link. What kind of noise figure you need to achieve for that?
So the question is, what sort of noise figure can one achieve with our fiber optic links?
Yeah, also because you mentioned transport of very weak signal.
Okay,
so you need very good sensitivity.
Well, for our smallest modules, for when configuring a link that perhaps has unity gain or 0 dB gain end to end, the noise figure of perhaps one of our uncooled laser diode links that go up to 6 gigahertz, perhaps is on the order of 35 to 40 dB. Now we can add in the front end of the fiber optic transmitter a low noise amplifier, roughly plus 20 dB amplifier, and that would improve the noise figure of the fiber optic link by about 20 dB, and also increase the gain of the fiber optic link by 20 dB. For our cooled laser diode links, which are basically the fiber optic links that are above 6 gigahertz,